Okay, guys, we're going to cover in your notes page 102, and our topic today is synthetic division. Okay, so yesterday you guys covered long division, right? And synthetic division is another version of dividing polynomials that we can specifically use for simple cases, right? When the divisor is linear. What that means is, again, x minus r. You can't have a number in front. So let's make a note of that, right? No number in front. Okay. So if you have something like 2x minus 3, that would not work, right? But anything that's simple, just x minus a number or x plus a number, those would work, okay? Now, here they mention we have to make sure we follow the same conditions that we did with long division, okay? So standard form, first of all, everything needs to be in order, right? In terms of the exponents, both of your terms, right? Missing terms, no gaps in your order. If there are missing terms, you should fill them in with zeros. And we're going to write the remainder the same way we were writing it before. We're going to write it as a fraction, right, over that end piece, right? So in order to use synthetic division, we're actually going to take the divisor, that x minus r, whatever we're dividing by, and we're going to use the solution for it, right? And that's going to be the number that we use to set this up, okay? So let's try one, and you'll see kind of how we set it up, okay? So on this first problem, we're going to take x minus 4, and if we solve this, we say x minus 4 equals 0, and we just get x equals 4. Now that's just a basic solution, right? Finding a 0, okay? And we're going to draw a little window, and we'll put our 4 there, okay? Now, across the way from here, we're going to write all of the coefficients from this polynomial. Now notice I'm not writing any of my x's, right? I'm only writing the coefficients or the numbers that are there, okay? Now, after I've done this, I leave a little bit of space, and then I'm going to draw a flat line. That's going to be kind of like my equals bar, okay? So now here's where the math starts happening, right? The first number is just going to come straight down. We're going to bring that 1 down. And now what we're going to do is we're going to multiply 4 times 1 and get 4, okay? And then we will add them together and get 2. Now we're going to repeat this process. 4 times 2 is 8, and then we'll add them together, and we'll end up with negative 14. We can multiply these two together. We should get, what, negative 56, right? So, again, we can add, and we'll get negative 16 as our final number, okay? Now, this last number you get is going to be your remainder. Let's make a note of that. Okay? So, again, what did we do? We multiply this way. And then we're going to add that to the next term right here, okay? So you take 4 times 1, write it here, and then you add the two numbers together. Okay, so what is my actual answer here? Okay, so I started with x cubed, so now my terms have 1 degree less, okay, because remember when we divide, things get smaller. So now this is x squared plus 2x minus 14, and my remainder was minus 16, so we can just write minus, remember your remainder is going to have that divisor at the bottom. So 16 over, my divisor was x minus 4, okay? Now let's note again, this, the exponent is 1 less than the start, okay? So if this was x to the 5th, this would lead out with x to the 4th, okay? And so on, it always counts down. So we went 2, 1, no x's, and then the remainder, okay? This last number will always be your remainder, okay? Let's do one more together. So if we take a look at problem 2, okay? Again, we need the solution for this, right? Not 8, but -8. All right? So now I've got, again, my coefficients, 1, -5, -20, -32. Again, we just write down the numbers, don't write down the x's. Okay? Let's add our equals line. Okay? And the first number, again, is just going to come down. Okay? So that 1 is just going to come down. All right? So what were my steps again? Let's think about it. Remember, we used multiply and then we add, right? So -8 times 1 gives me -8. And then we can add these two together. This will get -13. Okay? -13 times -8, right, is going to give me 104. Okay? And when I add these two together, I will get 84. Okay? Now, if you just think about what we're going to do, again, same step, we're going to multiply -8 times 84, right? Hint, you probably just use your calculator. You don't have to do this by hand. And you should get, what is it, 672, I believe. So -672, right? And that's going to give us -704, right? Some ugly looking numbers here. But that's okay, right? Again, process is still pretty simple. All right, so now let's remember this is my remainder. Let's just note that. And let's get our answer from this point, okay? So again, I started with x cubed, so my answer is 1 degree less. So x squared minus 13x plus 84 minus 704 over x plus 8. Okay, so yeah, some crazy number, but still pretty manageable math-wise. Okay, so again, let's walk through these steps. Okay, move your first number down, then multiply, write your result here. Once you have those, add, repeat, multiply, add, multiply, add. Okay? So as long as you follow that pattern, right, you're going to multiply, then add every single time. It'll get you to your result. Okay? Watch out. In synthetic division, we add, not subtract. In long division, we always had to subtract. In synthetic division, we are going to add. And the reason is kind of because we flipped this sign to start. So because of that, we're kind of handling the subtraction up here. Okay? But remember, multiply the two numbers and then add. Okay? So I'm going to leave these two up for a second in case you missed something as I was going through this, right? Maybe pause and take a second to note these down. Okay, I'm hoping that you have both of these down. Remember, your steps were to multiply the two numbers, right, 4 and 1, and then write that result and then add them together, okay? Now, let's take a look at the next one, okay? So the first thing I notice here is that this is not in order, okay? So let's put this in standard form. Okay, so standard form means we've got to lead out with the highest exponent. So x to the 5th minus 5x to the 4th plus 6x cubed minus, no x squared, so plus 0x squared plus 5x minus 15, okay? So all I did was I wrote it in order and I filled in this missing term here, right? So let's just note that's a missing term. So I filled in that 0. Okay. So let's set up our problem once again. Okay. So what do I write out? Remember, we're only going to write out the coefficients, these numbers, right? So there's my imaginary 1. 1, -5, 6, 0, 5, and -15. Okay, and I'm dividing by x minus 3, so the number I'm putting here is going to be 3. Okay, always with that sign flipped. Okay, let's draw our little equals bar. Okay, and always leave a little bit of room. You want to leave some space. Okay, that way you have room to write numbers here. Okay, so what does my first number do? Okay, hopefully you remembered that the first number is just going to come down. Okay, so the first number comes down. I've got a 1 here. 3 times 1 will give me 3. Now we're going to go add these two together. We're going to get -2. 3 times -2 is -6, right? -6. And when I add these together, I'm going to get a 0. Uh-oh, that's a little strange. 3 times 0 is 0. I can again add, get another 0 here. And 3 times 0, oops. Add these two together, and now I've got a 5. 3 times 5 is 15. And I've got this remainder of 0. Okay, cool. Again, this is my remainder. I'll keep stressing that. Okay, so let's come up with what our answer is, right? Try it yourself, see if you can come up with it first. Okay, hopefully you remembered this degree is 1 more than what my answer will be. It's always, this is take 1 down, right? So this will be x to the 4th minus 2x cubed plus 0x squared plus 0x plus 5. Okay, so these were the 2 zeros and then the 5. And I don't have a remainder, so I'm not going to write it. Okay, now, sorry, my work is smudged a little bit, but if you take a look, what's my final answer going to look like? X to the 4th minus 2x cubed. I don't need these zeros anymore, so just plus 5. Okay, that is my result. All right. Cool. So I'm hoping that you guys are taking away the steps, right? Bring the first number down. Multiply. Write this number. Add. Multiply that. Add. Multiply. Add. Multiply. Add. Right? We're going to keep doing that until we're all the way through here. Okay? And your final answer is always 1 less exponent. Okay? So if we want to note that again, exponent is 1 less. Right? So compared to here, we are 1 less down here. Okay? So let's check out the last problem on here. Okay? So this problem actually was already on our long division section, right? This was number 2 in the long division section. So if you flip back 1 page, you should see this same problem. Let's make sure that we get the same result though, okay? So just let's make a note that this is also on page 101. Okay, so the first thing you should note here is there are missing terms, right? So let's fix that before we get any further. X cubed plus 0x squared plus 0x minus 27. Okay, so that is my first polynomial that I need to divide, right? So let's set up synthetic division. I have minus 3 here, so I'm going to put plus 3. Let's take this and fill in the coefficients again. 1, 0, 0, -2, and put my little bar down here. okay? Again, what are my steps? Okay. Take a moment, see if you can solve this problem, okay? And I'm going to go through it. Let's bring the first number down. Then we multiply. 3 times 1 is 3. Okay. Let's add 0 plus 3 is 3. 3 times 3 is 9. Right? I'm obviously forgetting to write out the full coefficient. It's supposed to be 27. And 0 plus 9 is 9. 3 times 9 is 27, and that's going to add up to 0. Okay? So again, my exponent is 1 less than I started with. So I started with a cube, so this is going to be squared. So I've got 1x squared plus 3x plus 9. Okay? And that's kind of my final solution. And I know you don't have to write that one. I just kind of wrote it in there for you guys. Okay? So this is the process for synthetic division. Okay, we worked a couple of examples, right? If you follow those 2 steps, right? Remember, we're always going to multiply these numbers, rewrite, and then you add them together. And you keep doing that, this bottom row becomes your answer. Remember, it's always 1 exponent less than what you started with, all right? So synthetic division is significantly shorter and easier to write out compared to long division, right? If you go back and look at your long division notes, you'll see that we had to write out significantly more stuff, okay? So very handy tool, but remember the restriction for this, okay? Your synthetic division setup only works if this is a linear divisor. There is no number in front, okay? So let's see what else we can learn using synthetic division, right? So as we continue down this page, they mention something called the factor and the remainder theorem, okay? So what we kind of learn from this is, remember, every factor can give you a 0, right? So what they point out is, if you do synthetic division and your answer gives you a remainder of 0, okay? So for example, this last problem that we solved, actually these last 2, but where the remainder was 0, okay, we know that x minus 3 that I divided by is a factor of this, okay? And if you took this number 3 and you plugged it in here, you would actually get 0 by setting it up, okay? So what we're getting at is, if you took this number that you find here, right? So for example, on the previous problem, it was 3, and you plugged it into your equation, it would give you back to 0, okay? And that's just because if you get 0, you know that that's a solution. It's one of your factors. Now, if you get a number, then that is actually also the remainder, right? So this works in both ways, okay? So if you solve an equation by plugging a number in, whatever you get is the remainder of if you had divided by that, okay? And if you divide and you get a remainder, that's also the same as if you had plugged the number in. Now that's all very confusing to see. Let's see if we can't put it into some action and make more sense of it. Okay, so question 1 says, determine if x minus 5 is a factor of this polynomial. Okay, so if x minus 5 was a factor of this, we'd be able to say that by dividing, I should get a remainder of 0, okay? So if something is a factor, you know that the remainder is 0, okay? Let's see if this is actually true, right? So I'm going to use synthetic division again, since that's what we've been practicing today. So again, x minus 5, we have to set it equal to 0, and we're going to get 5 as our term to divide by, okay? So we'll put our 5 here. Remember, we write only the coefficients. Thankfully, they gave it to us in standard form and no missing terms. So I'm going to have 2, 7, 2, 1, and leave some space. Let's draw our line. 2 comes down. 2 times 5 is 10. Add these two together, we're going to get 17, right? We'll get 85 when we multiply them, which becomes 87, and I believe this is 435. Ooh, some crazy looking numbers, okay? So this is my remainder, right? And it's not 0. So we can note that this is not 0. And our conclusion is that x minus 5 is not a factor of this polynomial, okay? Now, a little piece of bonus information that we learned doing this, okay? So you know we have this piece right here, okay? And if I just said, hey, this is f of x, well, by doing this, I actually learned that f of 5 is going to equal 436, right? Because we got that as my remainder, okay? So this is just bonus information that we learned, okay? We said, hey, the number, when I plug it in, will give me 436. And again, that's because this was my remainder that I got. So you can work both ways, right? You can say by plugging it in, I can figure out the remainder. So if this was 0, we'd know this is a factor. But we could also use synthetic division and discover what the value is. Okay. So if you actually wanted to take a second, you can plug 5 into here, and it will give you 436. Right. Okay. Now, number 2 actually is asking us for the reverse, okay? And it says, hey, can we figure out what the remainder is without dividing, okay? So remember, we said that when I found this remainder, that was because of 5, which is the solution to this, right? And if I had just plugged the number 5 in, I could also have found that remainder, okay? So let's see if we can do it the other way. So again, guys, this is written as a fraction, but that's still just a division, okay? And so if I take this bottom part and I say, hey, x plus 3 equals 0, so x is going to be negative 3, right? And if I take this top piece right here, okay, and I'm going to plug in negative 3. So let's note, we're going to plug this in. Oops. Super messy. Okay, so let's write it out. We've got negative 3 cubed minus 13 times negative 3 minus 12. Okay, and we should be able to get the remainder just by doing this math. So negative 3 cubed is negative 27 plus 39, okay, minus 12. And if we put it all together, you should get 0, okay? Let's check our work, okay? So we did the work here. Let's check our work. So let's prove that this is supposed to be our remainder, okay? So in order to prove it's our remainder, let's go ahead and set up synthetic division, right? So again, over here I'm going to put the negative 3, and missing term, watch out guys, 0, x squared minus 13x minus 12. Write out your coefficients, 1, 0, negative 13, negative 12. Flat line. You guys should be experts probably by this point. The first number is coming down. Multiply, add, multiply, add, multiply. And then we add to get our remainder, right? Notice this remainder is the same as what I got here, okay? So this is what we wanted to do. This is just us checking our work, right? Note that these are the same, okay? So this is without dividing. This was just us checking our work, right? So remember, if it says don't divide, okay? But we also learned from this, right, that x plus 3 is a factor of this polynomial, okay? So, to sum it up, right, you should be able to now use synthetic division, okay? And you should be able to plug in the factor and remainder theorem to help you make some conclusions, right? So remember, if you get a remainder that is 0, then you know something is a factor, okay? And if you get a remainder that's actually a number, you can figure out what actually that value is. So we can actually compute long polynomials without plugging any numbers in, right? We just do synthetic division instead. If you wanted to know what the remainder was without dividing, remember, you can just plug in the solution and see what you get, okay? All right, I hope you learned a lot, and good luck with your homework for the rest of the week.